All right, so here we go with the proofs, the 4 on their own proofs, 100% on our own. So let's get started, jump into it here. I will go ahead and again, we'll put the givens here. So we'll say, you know what, GH is congruent to JK. And then we can also say that HJ is congruent to KG. And again, they're both given. And again, I'm not done with the givens yet because I have to make sure to mark them on the diagram. Now, in this case, GH is here and JK is here. And we have HJ and KG are here and here. In other words, they're already marked on this diagram, but to double check that they were, okay? And then the next thing we look at is, well, again, I'm trying to prove these triangles congruent here. That's the whole goal. My goal is proving these two triangles congruent. We'll have two sides, and I look at that diagram and I actually say, oh, look, we have a shared side, right? So that side, JG, right, that's going to be congruent to, well, side JG. And again, the reason is because that is, as we well know, that's the reflexive property of congruence. And then finally, well, that's it. Actually, we look at those triangles and we say, well, what do we have? We have three sides. Three sides is easy. There's no where the angle is in relation to them. It's just three sides, side, side. So again, we know the reason that triangle GHJ that is congruent to triangle JKG is because of side congruence. Right? We don't know anything about angles. We don't know anything about if they're right angles or right triangles or parallel lines. We don't know any of that, but we don't need to. So we're good. All right, let's go slide over here a little bit. There we go. So we have, let's fit all these in here. All right, so we have some given information here. We have that AE is going to be congruent to CE, and we know that AB is going to be congruent to CD. And again, we look up here and we say, okay, they're marked already, so we're good. I'm just going to sort of mark them A, B, C, D, A, E, E, C, E. Okay. And again, so they're already marked and those were given. Make sure that they were, if they, right? Okay. And then the second step, well, we have more given information, right? There's actually more given information that I could actually write under this given, and that is that E is midpoint of BD, right? B is the midpoint, E is the midpoint of BD. That's still a given, so I'll go ahead and leave it up there. And I'll move this down a little bit, just so we're good. Okay, so step 2, though, well, if E is the midpoint, it's saying it splits BD in half. So then because E splits it in half, it's the middle, I know that BE and ED are the same. So not only do I mark it, but once I mark it, I come down here and say, well, I know that BE is going to be congruent to ED. Again, that's just because this is the definition of what midpoint means, right? If you have a midpoint, it sort of splits a segment into two congruent segments. All right. And then finally, we know we have enough information, right? The triangles are congruent. Triangle EAB is going to be congruent to triangle ECD. And again, the reason there is because of, well, there's three sides, side congruence. All right, let's go down here. All right, we're looking at this one. And again, just to get my game plan here, I got reflexive going. I guess I don't have the givens, they're right up there. I only know one piece of given information, and that's JM is congruent to LM. Now, I say that, but we actually know more than that, right? So that is given as far as just facts go. Hold on. I don't know if the mic's doing that or if my headphones are being weird, but either way, hopefully we're okay. But so we have sort of, that's given information, but there's more that we know because, yes, I can mark those congruent, and I should. But in this diagram, it marked angle J and angle L right angles. So I'm going to actually put that. So I'm going to say angle J and angle L are right angles. And again, that also is given, but more specifically, I'm going to show that it's sort of in the diagram. Sorry if you can't read that, but it says given in the diagram. All right, and so now I'm looking, and we know that we should do reflexive. We should always be spotting that, so I'm going to go ahead and do that. Even if it doesn't prove that we need it, we do, but even if we didn't, it's still a good step to consider, and we know that is reflexive property of congruence. Okay, and actually we do have enough information right now, almost. Okay, almost, because what we have is these are right angles, and because they're right angles, they're congruent to each other. But we don't need that, because this is, if I look here, it's it's side angle. In other words, we have two sides, but the angle is not between them like it would be sort of in like over here, right? It's not there. Okay, so because it's not there, we actually end up with sort of side angle, which again we know isn't anything. But again, these are right triangles, so right triangles mean HLs on the table. And in this case, we have the hypotenuse, which is KM for both, and then the legs, which are JM and LM. Excuse me. So, which is great. So we actually do have enough to say HL. So we know that the reasons why the triangle are congruent is HL congruence. And again, but I'm not quite there yet, and I guess I should have done that yet, because I'm not quite there yet. Because in order for me to prove HL, I need to say, hey, these are right triangles, and we have hypotenuses, and we have legs. So we have the hypotenuse right here. We have the legs being congruent right here. But what I'm missing is, of course, the fact that they're right triangles. So I need to say, triangle JKM and triangle LKM are right triangles. And again, that's just the definition of right triangles. And again, the definition of right triangle says they have a right angle. And so I said, hey, look, they have a right angle. That was given. So now they're right triangles. Cool. So then finally, we can say step 5 would be that triangle. I'm just going to slide down here so I can write this in. But triangle JKM is congruent to triangle LKM. And we already said the reason. We know that it's going to be HL congruence. And again, that was the fact that they're, sort of right triangles. And again, you could just sort of say, just for signify. And again, if I could go back and do the other ones and say, oh, look, what do we have? Well, here's a side, here's a side, and here's a side. Here's a side, here's a side, and then here's a side, right? So again, you can mark the reasons, and sometimes it actually might help. We'll go ahead and go over here. Draw, bam. All right. So if we're looking here, we got a couple. We have one reason, and that X. So I'll start a little here. We have X is midpoint of both VY and WZ. So it's the midpoint of both. So that's the given. So what we can do with that and say, well, if X is the midpoint of VY, that means it's splitting VY in half. So that means if it splits it in half, that means we know that VX is congruent to XY. And not only because X is the midpoint not only of VY, but also of WZ, which means it's splitting WZ in half into WX and XZ, two congruent segments. Midpoint splits a segment into two congruent segments. So I could also say in the same step 2 here, that WX is going to be congruent to XZ. And so we can say that because that's just the definition of midpoint. Same reason, that's why I put them in the same step, definition of midpoint. And so now we have two sides, and we don't know anything else. So I'm going to look at the diagram, and hopefully we see, just like with reflexive, that we're saying, oh, well, reflexive and vertical angles are always good to look at. So we have vertical angles, and there they are. There's our vertical angles. They happen to make these triangles congruent, which is great. But what are those angles? Well, that's going to be angle VXW is going to be congruent to angle YXZ, or some other name for them that is the same. And again, that's just because, well, the vertical angle theorem, right? And that's just, vertical angle theorem says vertical angles are congruent. So you can feel free to write that as well. And so now we're at the point where we have some stuff, right? We have, here's a side, and here's an angle. Now, it doesn't matter, again, in the statements, it doesn't matter the order that we're, how we're getting these things. It doesn't matter the order that we're getting them in. So it's not side angle, which we know isn't one. We always consult the diagram to figure out where it is. So we sort of are looking and saying, okay, we have a side here, right? We have another side here, and we have the included angle. So we know that's going to be two sides and the included angle, the angle between them. So we do know the reason that they're congruent is side angle side congruence. And that's sort of stating, side angle side congruence is stating that these triangles are congruent because they have those sides, two sides, and if their included angle are going to be congruent. All right. We're halfway there. Nice. All right. So we look here. It says, all right, we're starting. We have, all right, PQ bisects angle SPT. And again, that is given. We have one more given. We can go ahead and write that as well. SP is congruent to TP. Now this I can mark right away because again, the bisects one not quite, but I can go ahead and mark SP is congruent to PT. But the first step leads directly into the next thing. It's saying PQ, this middle segment here, right, is bisecting. It's cutting SPT into half, right? So angle SPT is this large angle here, and this is coming along and splitting it right in half, which means that those two segments are going to be congruent. So this segment and this segment are going to be congruent. So I go ahead and mark them, but not only do I mark them, I actually will sort of say that, you know, what they are, and that's going to be angle SPQ, which is this angle over here, on the left side, is going to be congruent to angle, we said SPQ, so TPQ is fine, TPQ. And again, that's just because that's what angle bisectors are. So that's the definition of angle bisector. All right, so now we have the third thing. Well, we should be hopefully saying, oh, look, reflexive side. So PQ is going to be PQ. You'll see the theme with reflexive sides and vertical angles. If you see them, mark them. A lot of times when you have two triangles together, they share something. So reflexive property of congruence. So that shared side is going to be sort of one easy piece, okay? Now, basically what we have in this case, if I sort of just recreate one of these triangles here, is that we have a side here, and the angle that we know is congruent is between, and they match up on both sides. So we actually do know the reason right now, and we have enough information to that side angle side is what our reason is. And again, that is just proving that triangle, and how do they put it? Triangle SPQ is congruent to triangle TPQ. Okay. And again, if we really wanted to look at that, we could say, all right, well, this is a side, right? This is an angle, and this is a side, and where they are is side angle side. Two sides, one angle is what I'm getting here. In other words, I know I have enough to at least check that they're congruent. They are because of side angle side, and we're good to go. So sort of keeping track of which, you know, how many sides, how many angles you have is good and be good and important. All right. So we have a couple pieces of given information. The first one is that D is the midpoint sort of AC. And again, that is, of course, given. But there's another piece of given information that I want to put as a separate step, and that is that angle BDC. And not only that, because if they're marking one, we actually know that they're both right angles. So angle BDC and angle BDA are right angles because that was given, but in the diagram. Okay. All right. And so let's go back to the original statement here, or the given information. It says D is the midpoint of AC. So if D is the midpoint, it's splitting AC in half. That means that this segment and this segment have to be the same because D is right in the middle. So in other words, AD has to be, segment AD that is, has to be congruent to segment DC. And again, that's just the definition of what a midpoint is. Midpoints split segments into two congruent segments. So we had a midpoint in step 1, therefore we have two congruent segments in step 3. So we also, again, there's a theme, reflexive side, BD. So BD is going to be congruent to BD. It's NBD here. No big deal. And then so we have reflexive property of congruence here. And then so finally, we're looking, what we have, I'll just sort of sketch it out. We have a triangle where we have this angle. I missed something. Because what I'm looking at is like, so far, what do I have, right? I have explicitly saying we have a side here, right? We have a side here. Now, they are right triangles, but those are both legs. So we know it's not going to be a hypotenuse leg because what I have is two different legs. So I have, this and this. So hopefully we see that at side angle side, but I didn't say that these two angles were congruent. So I need to actually say that first. I need to say, you know what, those two angles are congruent. And how do I know that angle BDC is congruent to angle BDA, sorry. And that would be because, well, they're both right angles. So how do I know that two right angles are congruent? Because that's the right angle congruence theorem. In other words, all right angles are congruent. Right? That's what the right angle congruence theorem says. So either write it out or write out the abbreviation for right angle congruence theorem is fine in that case. Okay. And so now finally we have, right, we finally accomplished this angle. So now we have two sides and one angle that we can work with here. And so we are doing that. So now we can say that triangle ABD is going to be congruent to triangle CBD. And again, the reason is because if we look over here, we have two sides and they're included angle. They're right angles, but they're still congruent angles. So we have two sides and their included angle, the angles between those two sides, it's formed by those two sides, little side angle side action. All right, finally we get the last two. Okay, so we have a couple of statements here. We have angle NKM is congruent to angle LMK. We also have angle L is congruent to angle N. Angle N. And again, those are given. And not only that, but I go back in the diagram and they're marked. They already are marked. Now, in this case, we have triangles that are overlapping. So I'm just going to sort of highlight what the ones that I'm kind of looking for here, because I'm trying to prove that NMK, so that's NMK, so NMK, right, is going to be congruent to LK. Those are really well done. Great work. Okay. All right. So what we have so far, and again, I'm just going to recreate one of them, right? What we have so far, actually, I'm going to recreate both, is if we look, we can say that these two angles are congruent to each other, right? And then this angle down here is going to be this angle right here. And this angle down here is going to be this pointed end of this triangle. So we actually have two angles so far are congruent. Now, this is maybe tough to see, but we actually should see that there's a bit of overlap. When I highlighted them, I highlighted one side twice, right? This side here is highlighted twice. So that's my next step, is to say, you know what, KM is going to be congruent to KM. And that is reflexive, and it's a common thing. We've been doing it the whole time, but it's harder to see than because of how they're overlapping. So it does help to sort of either highlight the two triangles, pull them apart, and we'll see that, okay, well, this bottom side KM is on the bottom of each of them. It's the same, right? So if you highlight them, then where you're highlighting twice is where the overlap is. Again, we know that is just because of the same of each. We know that's reflexive property of congruence. It's saying KM is congruent to KM. And then finally, we're actually done in this case, because if we look at the triangles, we have two angles, right? And the side that we know is not included, it's not included, right? So we know that we have two angles, and then the side is not between them. So we have angle side is our reason. Angle side is our reason for congruence. And again, that proves what we're trying to prove, and that's triangle NMK is going to be congruent to triangle LKM. All right, last one. Giving us some information here. We know that, I'll just write these first two steps out. We have Vx is congruent to xy. So I'm going to mark that. Vx is congruent to xy. Again, that just tells us something, so I can straight up mark it. And then we know that xw, let's try that again. Nope, good work. Whatever that happened. Okay, awesome, amazing. Let's just get an eraser. All right. So we know that xw is going to be congruent to yz, and again, that straight up tells me something. xw is congruent to yz, and again, that's just given. Okay. And the second thing that we know that also is given is that I didn't have room for it, so I could keep it in the same step if I wanted to. But xw is parallel to yz. So I'm going to mark them parallel. So not only are they congruent, but they're parallel. So now I'm sort of thinking that these lines are parallel like this, and there's only one line that goes through those, and that's the sort of line VY, sort of along the edge over here, right? So this line is my transversal. And so what, part of this, like as far as these parallel lines go, like which angles. So when I have parallel lines, I'm immediately thinking I'm dealing with angles because I have all, corresponding, alternate interior. We have certain pairs of angles that will be congruent if lines are parallel. So in this case, I'm just going to finish that one out. So in this case, what do I know? Because I'm looking, I have a triangle here and I have a side and a side. So I basically need another angle or another side. So I'm looking, but I'm dealing with parallel lines. That's telling me about angles. So this angle right here is actually this angle right here. And this angle down here is this angle right here. So those are the only two pairs that are part of, is part of each triangle. And so those right here, we hopefully recognize that they're corresponding angles. So I do know for a fact that, angle VXW is congruent to angle XYZ. And that's because, and the reason is, well, if these lines are parallel, right, then we know that corresponding angles are going to be congruent. Corresp. Okay. And again, that's also corresponding angles postulate. But again, we're good there. All right. And then finally, we do have enough because we know that now that angle, right? So we have two sides and they include an angle, two sides and the angle that's included between, right? So we can have enough to say that triangle VXW is going to be congruent to triangle XYZ. And of course, the reason is that we said was because we have two sides and the included angle are congruent. All right, there it is. See you next time.